One only. One bit.
Recording in progress.
More what is our Clear and Ariel. Clear.
Sir,
Are you able to hear me?
now I am able to hear you, sir.
Okay. Is my voice coming as one or two?
Echoing, sir. It's echoing a little.
It's going right. Get started. Confirm if my voice is clear now. Can you confirm if it is clear now?
Now it's clear. Sir.
Okay. Is it better? Like,
It's better. Sir.
okay. Yeah. So we shall get started. Yeah. So write down the next heading as collisions. So topic we are going to discuss is collisions. So generally when you discuss in a common language, right? So when we discuss in a common language, what does the meaning of collision that comes to our mind? So when we see this, what does collision mean according to us? For example, let's say there is a carom board, right? You have the holes here and you have a coin and a striker, right? So when you hit the striker towards the coin, what is going to happen? The striker goes in, touches the coin, as a result of which the coin starts moving, right? So can I call this process as collision, right? That's what we understand from layman point of view. That is called as collision, right? So basically, if you go slightly deeper into what is this word collision doing with respect to the striker and the coin, can I say that there is a slight transfer of energy taking place from one to another, right? So what is actually happening? The striker, which was hit here, started moving. So when it started moving, it had some kinetic energy. And that kinetic energy is getting converted or it's getting transferred to the coin through the process of this collision. As a result of it, the coin which was initially at rest also started moving, right? So this is what we feel collision is, right? But according to physics, collision has a slightly different perspective. Yes, of course, when this kind of a thing is happening, yes, it's called as collision. Means if there is a physical contact existing between the two objects which are trying to collide, okay, you call it as collision. But if you go back to the concept of atomic structure, right? So there is an experiment called as alpha ray scattering experiment. So when you talk about it, the alpha particles, what are alpha particles? Basically, they are helium 2 plus nucleus. So they are positively charged particles. When they move towards the central core, what was observed? When they move exactly closer to the central core, the alpha particles were not able to touch the central core called as the nucleus. Rather, they went till a certain distance and took back a turn of 180 degrees. Right? That's what the experimental observations tell us. Right? Now, if you see, according to physics, though there is no physical contact existing between both these materials, you can still call it as collision. Am I clear? Are you able to understand what does collision mean? So collision on a higher level in terms of physics has a meaning related to how the energy conversion and momentum conversion are taking place between the objects which are involved in the process, right? So having all these things in mind, let's try to understand or give a definition to what exactly collision is all about, right? So make a note. So the definition when we take it, right? It is an isolated event, okay, in which two or more colliding objects exert relatively stronger forces on each other for relatively a shorter time. Right? Did you make a note of it? Yeah. Now see, if I try to look at the meaning of what we are trying to say. So when I say the event is isolated means there are certain objects that are participating in the collision. For example, when we took the collision example with respect to a carom board, it is an isolated event that is taking place between a coin called as a striker and the coin which is used to play. Am I right? So you have a striker and you have a coin which is targeted, right? So in which two or more colliding objects exert relatively stronger forces on each other for a shorter duration of time. What is the meaning of it? So if I have to visualize the situation, initially before you hit the striker, it would have been at rest. Similarly, if you look at the coin, it would have been at rest, right? So when you give an impulse here, what is happening? It is moving. So listen to this word. I use the word impulse. What do I mean? I exert a force, but for a shorter duration. So it starts moving along a particular line of action. So there is a particular path along which it is actually traveling. Am I right? So it goes and strikes the object which is at rest, as a result of which, at the time they both come in physical contact with each other, there is a force exerted by one on the other. Am I right? So if I take this as A and B, there is a force exerted by A on B in this direction. And similar will be the case of force exerted by B on A, which is exactly in the opposite direction. And this is happening according to Newton's third law, right? So as a result of which, during the time of collision also, if you see the external force that is acting on the system, what is it going to be? It is still going to be a zero, right? So after collision, what will happen? The external force acting on both the objects is again going to be zero. So I come from the beginning. Initially, the external force, when they were not in contact with each other initially, the external force acting on both the objects was zero. During the time of collision, it is zero. After the collision, they get separated. Then also the external force acting on it is zero. So this is where an important question that gets arised is, just give me a minute. I wrote on the wrong slide. So what were we discussing? What was I telling? During collision, after collision, right? Yes. So if you observe, before collision, during collision, and after collision, the force acting, the external force acting on the whole system is zero. So this is where an important theorem that comes to our mind is conservation of linear momentum. So what does conservation of linear momentum state? So when you talk about conservation of linear momentum, what comes to our mind? When external force acting on the system is zero, linear momentum is said to be conserved, right? So you're able to understand what I'm trying to say, no? So what can I say, or what is the important conclusion we can draw in this? So we can say, in the process of collision, in the process of collision, linear momentum is always conserved. Am I right? So linear momentum is always conserved. Now comes an important question, right? So first we try to understand what exactly collision is all about. The second type is we need to understand if at all collision is defined in this way with respect to physics, how many classifications can we draw from the concept of collision, right? So if you look at the concept or classification of collisions, they are basically classified like this. They are classified as elastic or inelastic, or thirdly, we call it as perfectly inelastic. Is it clear? So now we are going to connect the dots, right? So let us try to understand the whole story. First, we told that, okay, this is what is collision. Then one important conclusion that we could draw from the concept of collision is linear momentum is conserved. It is always conserved. Now the next question is, I mentioned that collisions can be classified as elastic and inelastic. Basically, these are the two broad classification. If you look at the third word, I would say it is a subclassification of inelastic collision because we are using the word perfectly inelastic. So it is under inelastic only, right? Now my question is, whenever there is a classification taking place, there should be a slight differentiating factor. So any classification will have a differentiating factor. Now, what is the differentiating factor we are using to classify them as elastic and inelastic? So that is where the question comes. One thing is, whether you talk about an elastic or inelastic collision, it is observed that linear momentum is always conserved. No doubt in that. So when I say collision, even before I broadly classify them as elastic or inelastic, one blind conclusion that I can make is linear momentum is conserved. No doubt in that. But the second question is about energy. Because when the objects are in motion, right? If any object has a mass and it has velocity, there are two important parameters we can define, right? One is linear momentum, which is mass into velocity, and the second is kinetic energy, which is half mv square. If you observe, both these parameters are dependent on mass and velocity only. Now comes the next question. So, if I have to call any collision as elastic, then what should happen is linear momentum is anyways conserved. Along with linear momentum, if I have the kinetic energy also conserved, then it is classified as elastic collision. Whereas, if linear momentum is conserved, but kinetic energy is not conserved, then you can call this as inelastic collision. So now we are going to see about each in detail. So first we will start with elastic collision. So let's get started with this. So you can write it like this: a collision in which there is absolutely no loss of kinetic energy. Okay. So if I see the basic characteristics, so when I say basic characteristics, these are all the properties it will start exhibiting. When I see the basic characteristics, first is linear momentum is conserved, and second is kinetic energy is conserved. So from this, an important conclusion that I can draw is kinetic energy is not lost in the form of heat or sound energy. It is not lost, right? And most importantly, what you can say is forces involved in elastic collision should be conservative in nature. Should be conservative in nature, right? If friction comes, it will become inelastic. Because friction comes, there is a loss of energy. Making use of. Now, I'm going to explain the concept of elastic collision in one dimension. Okay. So first we'll complete elastic, then we'll go to inelastic. So write down the heading as elastic collision in one dimension. So basically, what do I mean by one dimension is, let us take two objects which are colliding. Okay. Let's say initially their velocities are u1 and u2, and I'm assuming that they both are moving in the same direction. Having said this, I can call this as one dimension obviously when I'm able to draw a line through them like this. Right? I'll call this as one dimension. Now the question is not about the line being drawn here, right? It is about how are these objects going to move after collision. So initially what is happening, I told that they were moving in the same straight line, right? But after collision, if they start moving along the same line of impact, line is called as line of impact, right? So even after collision, you are able to draw the same line of impact through both of them, right? Then this type of collision is called as one-dimensional collision. And in one-dimensional collision, we are trying to be specific by saying it is an elastic collision, right? So when you think of elastic, what should come to our mind? It should be like linear momentum is conserved and the kinetic energy is conserved. No? Let me say the mass of the first object is m1 and the mass of the second object is m2. So similarly, here also it is m1 and m2. Now, let us think of one fact logically. So this is before collision. So when I look at the process before collision, I'm saying that they both are moving in the same direction. Now my simple question is, when will the first object be able to touch the second object? Simple logic. So when will the first object be able to touch the second object? When u1 is greater than u2, right? On a counterpart, after the collision has taken place, if you look at the velocities, they are changing to v1 and v2. Now they are not the same, right? That is obvious because there is an exchange of momentum going to take place, right? But the question here is, for these two objects to never come in contact again, then what should be the condition? v1 should be less than v2, right? So this is what happens, right? Provided the mass of the objects are different. That's the story here, right? Now, what did I say? I told the linear momentum is conserved. So what we are going to do in this scenario is, if the initial velocity of the objects are u1 and u2 and their masses are m1 and m2, our job is to calculate what is going to be the final velocities after collision. And those values are supposed to be calculated in terms of m1, u1, m2 and u2. So that's what we are going to start with. So first, if I start with the concept of linear momentum conservation, then I can say m1 u1 plus m2 u2 will be equal to m1 v1 plus m2 v2, right? So from this, what I will do is, I will collect m1 terms. m1 into u1 minus v1 is equal to m2 into v2 minus u2. Let me call this as equation number 1. Similarly, since it is elastic collision, what else is conserved? It is the kinetic energy. So if I apply the kinetic energy conservation, then I can say half m1 u1 square plus half m2 u2 square will be equal to half m1 v1 square plus half m2 v2 square, right? So what gets cancelled here? Half is gone. So from this again, if I start collecting the m1 terms, so it becomes m1 into u1 square minus v1 square is equal to m2 into v2 square minus u2 square. And let this be equation number 2. Are you clear till this step? Make a note. Shall I proceed? Now see, if I divide the second equation with the first equation, we get m1 into u1 square minus v1 square is equal to m2 into v2 square minus u2 square divided by m1 into u1 minus v1 divided by m2 into v2 minus u2. So if that is the case, we can write this as m1 into u1 minus v1 into u2 plus v2 divided by m1 into u1 minus v1 is equal to m2 into v2 minus u2 into v2 plus u2, the whole divided by v2 minus u2. So U1 minus V1, U1 minus V1 will get cancelled, V2 minus U2 and V2 minus U2 will get cancelled, which implies M1 into U2 plus V2 is equal to M2 into V2 plus U2. Sorry, correction. So here we have M2. So M2 and M2, M1 and M1 will get cancelled. So we will get U2 plus V2 is equal to V2 plus U2, right? Wrong with me, wait. I made a mistake. It is not U1 plus V1. You also wrote the same thing, huh? You guys wrote the same thing. Yeah. So a correction. M1 into U1 minus V1 into U1 plus V1. A minus B into A plus B divided by M1 into U1 minus V1 is equal to M2 into V2 minus U2 into V2 plus U2, the whole divided by M2 into V2 minus U2. So M1 and M1 get cancelled, M2 and M2 get cancelled, U1 minus V1, U1 minus V1, V2 minus U2, V2 minus U2. So we get U1 plus V1 is equal to V2 plus U2, right? So we will calculate, we will rearrange the final velocities on one side and initial velocities on the other side. So we will get U1 minus U2 is equal to V2 minus V1. The reason why I wrote U1 minus U2 is because U1 is greater than U2. Similarly, V2 minus V1 is V2 is greater than V1. Right? So when that is a scenario, I can say this U1 minus U2 as relative velocity. But what relative velocity is this? It is the relative velocity of approach. Why do I call it as relative velocity of approach? Because these are the velocities when the objects are trying to approach each other. Similarly, if I take V2 minus V1, this is also relative velocity, but this relative velocity is of separation, right? So from this, what we can conclude is in elastic collision, relative velocity of approach is equal to the relative velocity of separation. Okay, which is a very, very, very important point to be noted. So those who are online are able to understand?
Yes, sir.
Yeah. Very, very important. Slightly lengthy. Very, very, very important. Let me know once you're done. Okay. Now, if you see, since u1 minus u2 is equal to v2 minus v1, this clearly implies that v2 minus v1 divided by u1 minus u2 is going to be equal to 1. Right. So, if I have to give a name to it, if you observe, it is the ratio of something. What is it? What is the ratio? It is the relative velocity of separation divided by the relative velocity of approach. So if you're able to define this kind of a term, it is called as E, which is called as coefficient, called as coefficient of restitution or resilience. Okay. And this coefficient of restitution has a number associated with it. So if the value of E is equal to 1, then it is called as elastic collision. If the value of E is less than 1 and greater than 0, it is called as inelastic collision. If the value of E is equal to 0, it is called perfectly inelastic collision. So I repeat, coefficient of restitution is defined as the ratio of relative velocity of separation to the relative velocity of approach. Hariharan?
Sir, understood, sir.
Is my voice clear or
Yes, sir. Yes, sir. Yes,
is
sir.
it jarring?
No, sir. It's very clear, sir.
Clear, no? Okay. Is it clear? No. Now, if you see, since u1 minus u2 is equal to v2 minus v1, from this I can conclude that v2 is equal to u1 minus u2 plus v1. And let me call this as 3. Now, what I will do is, I will use third in first equation. So, what will you get? The first equation is m1 into u1 minus v1 is equal to m2 into v2 minus u2. So m1 into u1 minus v1 is equal to m2 into v2 minus u2. So this can be written as m1 u1 minus m1 v1 is equal to m2 into v2 is u1 minus u2 plus v1 minus u2. Right. Now if you see, v1 is the unknown because that is the final velocity. All other parameters are initially known to us. So when you see, you have m1 u1 minus m1 v1 on the left hand side, that will be equal to m2 u1 minus m2 u2 plus m2 v1 minus m2 u2. Right. Now, if I take v1 terms on one side and everything else to the other side, right, then I'll have m1 u1 minus m2 u1 minus, sorry, plus m2 u2 plus m2 u2 is equal to m2 v1 plus m1 v1. Now, if you see here, the first two terms, u1 is common, so u1 is taken out, it is m1 minus m2 plus m2 u2 is added to itself twice. So added to itself, so you'll get 2 times m2 u2. This will be equal to m1 plus m2 into v1, which implies v1 will be equal to m1 minus m2 divided by m1 plus m2 into u1 plus 2m2 divided by m1 plus m2 into u2. And this is going to be the final velocity of the first object, and this is happening in one-dimensional elastic collision. Is it clear? So make a note of this. Want to go to the previous slide? Shall I proceed? Or the next page you want to copy? Want to copy this? Make a note. Done? Noted? Okay. See, listen. We calculated the final velocity of first object in one-dimensional collision. Now our job is to find what is the value of V2. So for you to have V2, what we will do is we will write V1 in terms of V2. So V1 will be equal to okay. So we know that since U1 minus U2 is equal to V2 minus V1. From here I can say V1 is equal to, sorry, from here I can say that V2 is equal to U1 minus, oh, I'm sorry. What sound is that? Sorry. So from here I can conclude that uh, V1 is equal to V2 minus U1 plus U2. Let me call this as 4. And again using this 4 in 1. That is, we have M1 into U1 minus V1 is equal to M2 into V2 minus U2. So in the place of V1, I'm going to replace with this whole expression. So I'll get M1 into U1 is as it is minus, you have a bracket. So V2 minus U1 plus U2 is equal to M2 into V2 minus M2 into U2, right? So you will have M1 U1 minus M2 V2 plus M1 U1 plus M1 U1 minus M1 U2 is equal to M2 V2 minus M2 U2, right? Now collect all the V2 terms and bring the U2 terms to the left. So M1 U1 plus M1 U1 will be 2 times M1 U1 minus M1 U2. This will come this side as plus M2 U2 is equal to M2 V2 plus a correction here. It is M1 V2. So here you will have, when this M1 V2 goes to the other side, it becomes plus M1 V2, right? Now, if you see 2 M1 U1 plus M2 minus M1 into U2 is equal to M1 plus M2 into V2, which implies the value of V2 is equal to 2 M1 divided by M1 plus M2 into U1 plus M2 minus M1 divided by M1 plus M2 into U2. So this is going to be the final velocity of the second object. Is it clear? So if you observe, they both look to be similar. I'll tell you how to remember. So before that, make a note of it.
Sir,
Yeah, tell me. Yeah, tell me, no?
your voice is a little faint, sir.
I didn't speak anything.
Okay, sir. I thought something was problem here.
I know that these expressions are big to remember, so I'll tell you how to remember them. If you see V1 or V2, they both are something into U1 plus something into U2. Similarly, V2 is also something into U1 plus something into U2. Now, if you observe the expressions, the denominator is M1 plus M2. Here also the denominator is M1 plus M2. So, here you have M1 plus M2. Here also you have M1 plus M2. But if you see the numerator, when you are writing for V1, you should write it as M1 minus M2. And here it will be 2M2. Similarly, when you're writing for V2, it starts with 2M1 and here it will be M2 minus M1. So this is the way you remember it. Did you understand the method? Yeah. So this expression, these two expressions are to be remembered to solve problems, or else you can't sit and do the whole derivation again. Shall I proceed? Now, based on this, there are some special, or we can call it as particular cases, in which the first one is when masses of both the objects are same. When masses of both the objects are same, then you can say M1 is equal to M2, and we will call this as M, right? So what is the value of V1 we have? V1 is equal to M1 minus M2 divided by M1 plus M2 into U1 plus 2M2 divided by M1 plus M2 into U2, right? So when I take these two values and substitute it here and here, what will we get? V1 will be equal to M1 minus M2 will become a 0. So 0 times U1 plus 2 times M, because M2 can be replaced with M. So 2 times M divided by M1 plus M2 is also 2 times M into U2. So 2M and 2M will get cancelled, which will be equal to U2. So V1 will be equal to U2. Similarly, when you calculate for V2, V2 will be equal to 2M1 divided by M1 plus M2 into U1 plus M2 minus M1 divided by M1 plus M2 into, okay. Now, if you substitute the values, this parameter will get nullified. So you'll be left out with 2M divided by 2M into U1. So it gets cancelled, which concludes that V2 will be equal to U1. So what is happening here? We can see that V1 is equal to U2 and V2 is equal to U1. So what is happening? When both the objects are of same mass, right, the velocities get exchanged. Means the initial velocity of the first object gets transferred to the final velocity of the second object, and initial velocity of the second object becomes the final velocity of the first object. Means velocities are exchanged. So we can conclude that velocities are exchanged. Clear with this? Right? So proceeding to the second part, when the target is at rest, means I'm taking u2 to be 0. Means the first object, let's say its mass is m1 and it is moving with initial velocity u1. And the second object m2 is at rest. So if I call this as the target, generally in terms of collision, the particle which is traveling towards the target can be called as a projectile. Okay. So because it is the one which is projected towards the target, right? So when this is going to be the scenario, again applying the formula, V1 will be equal to M1 minus M2 divided by M1 plus M2 into U1 plus 2M2 divided by M2 into U2, right? So here what is going to happen? U2 is 0. If you take this and substitute it to this value, then you will get V1 is equal to M1 minus M2 divided by M1 plus M2 into U1, right? So this will be the final velocity of the first object. Similarly, what is going to be the value of V2? V2 is 2m1 divided by m1 plus m2 into u1 plus m2 minus m1 divided by m1 plus m2 into u2. And we know the fact that u2 is equal to 0. Again, plug it here. So you will get the value as V2 is equal to 2 times m1 u1 divided by m1 plus m2. So from this, we can do a subclassification. That is, I'll call it as 2A, where U2 is 0, but what if M1 is equal to M2? Then, if you observe, V1 we got as M1 minus M2 divided by M1 plus M2 into U1. right? If m1 is equal to m2, if you substitute it here, we can understand that v1 will be equal to 0. And what about v2? V2 we got it as 2m1 u1 divided by m1 plus m2. 2m1 u1 divided by m1 plus m2. So if m1 is equal to m2, you will get 2m. So if I call this as m, then you will get 2m divided by 2m into u1, which will be equal to u1. So what can you understand? That v2 will be equal to u1. So the meaning of this is, when I have the first object, which is having initial velocity u1, and the second object is at rest, that is u2 is equal to 0, up this, if the scenario, correction. So if this is the scenario before collision, then after collision, we will have the first object coming to rest and the second object starting to move with the velocity of u1, right? Here. So this derivation is slightly lengthy. There's actually one concept. Okay. Yeah. So one minute. Slides are over. So today's document, I'll send it to you so that you can copy it. If there are any mistakes. Big file. Yeah. So the next scenario is, so the next scenario is 2b, where u2 is 0, but second object is very heavy, in the sense m2 is very much greater than m1, right? Again, writing down the formula, v1 will be equal to m1 minus m2 by m1 plus m2 into u1. So when m2 is very much greater than m1, observe this, m2 divided by m1 will be very much greater than 1, right? The meaning of this is m2 divided by m1 can be approximated to 0. Oh, I'm sorry, wait. Correction. So m2 is very much greater than m1 implies m1 plus m2 is very much less than 1, which implies m1 by m2 can be approximated to 0. So when you approximate it to 0, observe v1 will be equal to, I will take out m2 outside. So I will have m2 into m1 by m2 minus 1 divided by m2 into m1 by m2 minus 1 into u1. So m2 and m2 are gone. So m1 by m2 is approximated to 0 and this is also approximated to 0, which implies v1 will be equal to minus u1 divided by minus 1. I'm really sorry, getting too many calls here. Just a minute. Did you understand what is the mistake I made in the denominator? I wrote plus 1, Bala, I wrote minus 1. 1 minute. I'll write it again. Listen. So v1 will be equal to, if I take out m2 outside, I'll have m1 by m2 minus 1. And from the denominator, if I take out m2 outside, I'll have m1 by m2 plus 1, the whole multiplied with u1. So m2 and m2 are gone. m1 by m2 is approximated to 0. This is also approximated to 0. From this, what can we conclude? v1 will be equal to minus u1. Meaning, if a small object is thrown towards a bigger object which is at rest, right? If it is thrown with a velocity of u1, after collision, the first object will rebound with the same velocity u1. That is the meaning of it. So that is the meaning of v1 will be equal to minus u1. Okay. Similarly, if I take v2, so v2 will be equal to 2m1 u1, 2m1 u1 divided by m1 plus m2. So what I will do is I'll take out m2 outside. So 2m1 divided by m2 into m1 by m2 plus 1, right? Into u1. So what will I get if I combine this m1 by m2? So I'll get 2 times m1 by m2 divided by m1 by m2 plus 1 into u1, which is obviously 0. So velocity of the second object is still going to be 0 because it is a very heavy object. Are you able to understand? Is there any question in your mind? Is there something in your... Which one? Which one is 0? This one. Are you asking about this? Because m1 by m2 is there, no? m1 by m2 is approximated to 0. Right? So numerator becomes 0, 0 by 0 plus 1. Clear? Shall I proceed? We want to copy it. So there is one last point. Okay, I'll do one thing. I'll explain it. Listen, so that it gets recorded. So 2m1 by m2 into m1 by m2 plus 1. So since m1 by m2 is approximated to 0, the final answer will be 0. Meaning the second object will still continue to be at rest. clear? So last point in the special cases to see where u2 is 0, but second object is lighter, meaning m1 is meaning m1 is very much greater than m2. So this time what happens? This will imply that m2 divided by m1 is approximated to 0, right? So what is the value of v1 that we have? So v1 is equal to m1 minus m2 by m1 plus m2 into u1. m1 minus m2 by m1 plus m2 into u1. So what I will do this time is I'll take out m1 outside. When I take out m1 outside, become 1 minus m2 divided by m1, the whole divided by m1 is there. It become 1 plus m2 divided by m1. So m1 and m1 are gone, and you have a u1 here. So m2 by m1 is 0 and m2 by m1 is 0. So v1 is equal to u1. So what is that you're able to understand? Means when a heavy object goes and strikes a lighter object, the heavier object will continue with the same velocity which it had initially. Meaning there is a heavier object and a lighter object. So when the heavier object is hitting the lighter object which is at rest, the heavier object continues to move with the velocity which it had initially. Now we'll see what will happen to the lighter object. So if I take V2, V2 is 2m1 u1, 2m1 u1 divided by m1 plus m2. So if I take out m1 outside, here also if I take out m1 outside, it become 2u1 divided by 1 plus m2 divided by m1. So m1 and m1 are gone. So m2 by m1 is approximated to 0. So what will you have? You will have v2 is equal to 2 times u1, means the second object will acquire a velocity which is 2 times the initial velocity of the first object. Means literally speaking, it flies away. Right? The lighter object moves very fast. Are these points clear? So how many pages in the long notes? But one concept. How many pages did you get? 2.5? 4 pages, 4 sides. I generally don't speak in terms of marks. Yeah, there, by much. Remember, you write it. They not type it so practice it while you learn. You're learning for the first time with an iPad. Even if it is revision class, you have got this 10 minutes. Then continues. There is a technique you will be able to practice. all about elastic potential. Have two more concepts to be discussed. One is inelastic, perfect inelastic. Third one is elastic oblique collision. That is our beginning concept. Then in this chapter, there are two problems which are actually concepts. That is, one is the concept that we discussed. Vertical circular motion is actually a concept. So if it comes to configurates, they will ask me what is the use actually in a position. What should be the initial velocity at the bottom vertical to the vertical circular motion. This is times pi into g into L, where L is the length of the spring. What is the velocity at the bottommost point? We derived yesterday. Pi g also to know velocity at point A. And then velocity at point A is 20. Velocity at B is velocity at B is so the least value is, so when you draw it on a number, the least value you can take this by, after that you can put the limit. For them, if I have to write that that's equal to equal to by g, correct? Actually speaking, it should be like greater than or equal to. Because I was going to be able to complete the I am stressing much is they are very important in terms of commitments. Guys are writing our daily papers. Very difficult matter when you are facing problems. So the whole concept you understood how to remember the velocity of the wave. Anyways, without looking at your notes, tell me what are the values of V1, don't look at them. And you try telling me V1 is I told you a technique, something into take it to. So first bracket and second bracket, what should you write in the denominator? Let's see. So for V1, what should be the numerator for V1? M1 minus M2. And this side will have M2. Right? Then if you write for V2, something into
Sir,
yeah, you
I can't hear you properly now, sir. It's a little faint, sir.
next. What about V2? Hari, is it clear now?
Yes, sir.
What about V2? Something into U1 plus something into U2. Denominator M1 plus M2, M1 plus M2. Numerator 2M1, and there it is M2 minus M1. So having this, we have some special cases. In that, what is the first case that we saw? If both the masses are same, what will happen? The velocities will get interchanged. So V1 will become equal to U2 and V2 will become equal to U1. So the velocities get exchanged, or you can say interchanged. Then in the second case, what did we see? Second object is at rest. That is second case. So then we saw 2A, 2B, 2C. Second case, when the second object is at rest, what is the value of V1 we got? M1 minus M2 by M1 plus M2 into, obviously U2 is 0 ma. Correct? So U2 is 0 na. Appa V1 le enna varum? See, don't look at the book. Think of the logic. That's what I told. There is a pattern for this. And what did I tell you? U2 is 0. So in V1 and V2, where is U2 second term? So other term மறந்துருங்க. So what are you left out with? First terms. So how is the first term in V1? M1 minus M2 by M1 plus M2 into U1. What about V2? 2M1 U1 by M1 plus M2 into U1. So something by M1 plus M2 into U1 is common. Only part you need to remember is where it is M1 minus M2 and where is it 2M1. புரியுதா? So that's what we wrote. Based on that, we saw three other cases. What are they? 2A. In 2A, what did we discuss? Masses are equal and so the second object, the target is at rest. So then what happens? First object will come to rest and the second object will start moving. Okay. So generally, if you see, when a carom board coin is designed, right? I told you about the coins, no? Let's say you have a scenario like this. This is a striker. So generally, when you compare the diameter of the striker and the mass of it, is it equal to that of the coins or is it slightly greater? Generally, if you see, coins are made of wood, right? And they have a shape and a pattern. But when you see at the striker, it is with some other material. What material, let's not discuss, but some other material it is there, right? So if there is one coin here and you have another coin here, which are directly going towards the pocket, let's assume everything is in the same line. You're hitting, then what will happen? This will go and hit the coin. So this coin and this coin are going to be of same mass. So what will happen? The first coin attains some velocity. It goes and strikes the second coin, which was at rest. So you can see that this coin will come to rest and the second coin will start traveling with the same speed as that of the first coin. It will go and fall in the pocket. See, generally when playing, you will not have the velocity sensors and everything in mind. I'm saying how to visualize it. Are you able to understand? So this is one of the examples. Similarly, you have a scenario where what was 2B? Second, the one which is at rest, greater mass, and it is at rest also. Let's take the same carom board. Why to break our head? Okay, there is a coin which is here. Okay, and you have a striker exactly placed here. You are hitting this. What will happen? This will attain velocity u1 after collision. Now, this is going and colliding with the fixed part of the board. So this part of the board, that black color part, will be slightly heavy. So when this goes and strikes this, what is going to happen? Obviously, it will rebound. That's what we call it as back shot. Right? So when it is rebounding, what will happen to it? It will rebound with the same. What happened? What is the value of V1? V1 came out to be minus U1, means it will rebound with the same velocity. But what is happening to the second object? No sense of urgency for it. It's still at rest only. Right? What about the other case? So other cases, you have a heavier object hitting a lighter object. For example, a cricket bat hitting a ball. Right? When that is happening, what can you confirm? Or what can you say? So let's say there is a cricket bat which is going and hitting a ball which is at rest. So what will happen? So this bat will continue to move with the same velocity. But what will happen to this ball? It starts moving with a velocity which is double the value of the initial velocity which the bat had. Are you able to visualize? So you need not memorize anything. You just see the scenario, you can say what kind of situation it is. Because I approached in a direct way. See, if I had to set a paper, I'll set the paper in this way. I'll say there is a scenario where one of the objects is at rest. Okay. And the object which is at rest is lighter. Okay. I'll say a heavier object is coming and hitting the first object. Then what will be the scenario? Describe it. Or I will say there is a collision taking place between two objects where the first object continues to move with the same velocity, but the second object starts moving with the velocity double the initial velocity. Describe the situation. Then what will you describe as? It is a situation where the second object, the lighter object is at rest and the first object is heavier object. You're able to understand, you just need to know this concept so that you'll be able to present it better. Generally, they'll not make it that tough. But I'm saying your thought process should be more so that physics becomes easy. Puriyada? So, this is all about elastic one-dimensional. So, in the next class, I'll be completing inelastic one dimension, perfectly inelastic collision, and elastic oblique collision. And we'll do some problems based on it. Okay. So, one more thing is, we didn't have any test because this week you already had school test. I didn't want to disturb you. Next weekend, there'll be a test in loss of motion. Okay. So, you asked for an assignment, right? It is ready. So, I'll be giving an assignment also, solve that and reach out to me for any kind of clarifications. Is it clear?
Clear, sir.
So that's it from my side. Any other questions that you have?
No doubt, sir.
So I hope the concepts are clear. Go and revise. See. We'll wind
Thank you,
up.
sir.